Eventually. All right. Okay, you guys ready?
Yeah.
Okay, all right.
Not really.
Yeah, are we truly, really ever? Okay. Or did the world truly end in 2012?
Oh my god.
Okay. All right. Anyway. All right. Powers and roots of complex numbers. Okay. So see this thing right here? We're not doing this piece. We're not doing that. Okay. Because I can't pronounce it, so we're not even going to do it. All right.
So we don't need to worry about that?
Not part. But this one we do. This is the part that we are doing. And it looks like this.
The bottom.
What does N represent?
Number.
Try again. Starts with P, ends in hour.
Power.
There we go. Power.
Power.
Mouse
Yeah.
per hour.
Power. Did you say mom?
I said mouse per hour. I'm like,
Miles per hour.
Anyway, all right. So N is my power, right? N is the power. And so it goes, so when I'm actually going to take it from the CIS, the compact form right here, and it's so it's the radius to the power, and it's CIS, and it's whatever that number is that the power is, times my theta. Because remember, when I'm doing a problem like this, it's actually a repeated multiplication. So when we did like the warm-up today, it was a square. So it was times itself, right?
2 times.
Yeah, or it was plus the same angle. So I had the same angle twice. Okay, so same rule applies here. So let's turn this into a trigonometric form. All right, so if I were to graph this,
What form is it in right now?
what form is this?
A plus C, right? Oh.
Okay,
No, it says root.
this is rectangular form, right? We have to turn it to trigonometric form to be able to do this. So now, this is 1. So which way does that go?
right.
To the right 1 and up. Rad 3. So it's going to be right 1 and rad 3. So it's going to go something like this. So it's in quadrant 1. That's what I needed to get out of that. So it's going to be in quadrant 1. Okay. So step 1. Find the what?
Root.
R.
Radius.
R. Yes, radius. So R equals
2,
square root of
4.
1 squared.
Oh my god.
6, 8. Who do we appreciate? Okay. Anyway. Rad 3 squared, right?
4.
4. Okay. So, when I did all this on the inside, now go ahead. What number's on the inside? 4. Okay. So,
And then
square root of 4. So, R is 2.
2.
Step 2 is find the
Theta.
theta. Let's find the theta.
10.
Inverse tan.
Is
Of what over what?
30 degrees.
Y over x, so it's going to be,
rad 3 over 1.
so which is theta is going to be what?
60.
How do you see what you're writing?
I don't know.
Shadows right
I know, my big head's in the way. So, are we okay with this? This is my y over x, right? I have 60. Is this in the right spot?
Yeah.
Yeah, that is in the right spot, isn't it? This is the point where you look at it and say, all right, is it in the correct quadrant? Quadrant, I'm sorry.
You good?
Okay.
If it's in the correct quadrant, okay, yes, we're there. If it was in quadrant 2 here, I would have to add, yeah. So, all that other good stuff to try and figure out if it's in the right. So now, first, this is going to be 2 CIS of 60, right? Yes, right? So, it breaks up to this now.
Where'd they get 8 from?
See this right here?
It's been there.
This is the original problem.
Oh, I was only looking at the underneath.
It's alright, it's alright. So that's the original problem, so it's to that power. So, from my formula, what letter does 8 represent?
N.
There's my N, right? So if I back it up, so that would be an 8 here, so it's 8 here and 8 here. So I'm going to do it in compact form. So it's going to be 2 to the 8 CIS of
Wait.
60.
What?
60.
Why are you?
that 8.
Wait, but why? Okay.
8, 6. 8,
Those are. You can use either formula.
Yeah, it means the same thing. This is just the compact. I hate writing the whole thing out.
No, I'm talking about the bottom one.
Yes,
There's 2 right there, right? That's.
this is my problem that I started with.
Oh.
And this one over here is vanilla ice. Because if you got a problem, you'll all solve it. See? Man, I've been waiting all year long to use that show. Okay. Anyway. Alright, so this is the problem, and this is it, actually, where each item goes.
Alright, we're good.
Okay, so we already put that 8 in one place. Where else does the 8 go?
Besides 6.
Yes?
That's right there.
So there, so it's going to be an 8 right here, right?
Uh-huh.
Times.
Theta.
Does that make sense?
Yeah.
Pretty straightforward, right? We put the 8 where it goes. And now 2 to the 8th power.
2 times 2 times 2 times
2 to the 8.
So on your calculator, 2 carrot 8. What is it?
256.
256.
Yeah.
CIS of
60
Yeah.
times 8.
256.
480.
480.
Yes.
Ah, dang it. Okay.
Squared.
480, right? Okay.
So that's your answer?
Nope. This is my answer in what form?
Oh.
No.
Rectangle. No.
Powers.
I don't know.
Did more.
Rectangular.
Give him a hand. What is that? Theorem. I was gonna say trigonometry. I'm so weird.
In trigonomics. So it's in trigonomic form. And if you guys remember, the rectangular was a plus bi, right? Okay, so now, is this number right here on my unit circle?
Name.
Say no.
No.
So what do I have to do to get it?
Subtract 360.
There you go. Subtract 360. So it's going to be 256 CIS of...
120.
Very good. All right. Now, let's go ahead and convert it to rectangular. So I have to expand it now. So it's going to be 256, and it's going to be cosine of 120 plus I sine of 120. Okay, so now from this point right here, I find that unit circle, right? So cosine 120.
Cosine 120 negative 1/2.
Plus I and times.
Rad 3 over 2. This is the part where I get confused.
Okay, you got this part, right?
Yeah,
Are you okay to this?
Yeah.
Okay, so now from here we have to distribute.
Yeah. Oh.
So I distribute to the first one. So a positive times a negative is negative. So I have a negative what? 128? Negative 128.
Negative 120.
Okay, so over here distribute this way. A positive times a positive is a
Positive.
positive. So now, so all I have to do is 256 over 2. So 128, right? So it's going to be plus 128 I rad 3, right? Because the 2 on the bottom divided this out, but I still have that rad 3. And I still have that I there.
Wow. Is that the answer?
Hold on, hold on.
Oh. You didn't circle it.
Why? Why did I not circle it?
It's in
Because it's
rectangular
in
form.
rectangular form.
Very good, rectangular form.
Wait, what is this solving?
Alright.
Huh? What do you mean?
What is this for?
We started this problem right here. We started with this way over here.
Okay.
We started with a rectangular form and we took it to a power. We turned it to CIS to actually do the power. And now from there, after I did the power, now I could actually turn it back into rectangular. So it started rectangular.
Okay, so you're getting rid of the power.
Yes, I put the power in, so I'm actually doing that part. Okay? So that's it. Only one example. All right. Don't forget, like, subscribe, right?